Up until this point, we have been looking at how flammable atmospheres are formed and how the correct ratio of gas and air is required to form the explosive envelope. Let's now look a little closer at what happens when fire is created. Fire is a chemical reaction which needs three elements to be present: oxygen, heat, and fuel. These three elements combine to make what is commonly known as the fire triangle. When oxygen combines with flammable vapors or gas given off by a fuel source, heat is created at a molecular level. If there is a source of ignition nearby, this mixture will combust and cause a fire. A fire can be prevented by taking away any one of these three elements. Remove any one of these elements and the fire will die. Let's revisit how we measure gas in air below its LEL. Gas amounts in air below its LEL will not have enough fuel to react with the oxygen in the air, and therefore it will not burn. However, once the gas-to-air ratio of the LEL has been reached, there will suddenly be enough fuel and oxygen for the mixture to become flammable. If a source of ignition is present, then a fire will start. By understanding how the fire triangle works, you can implement direct measures to prevent or fight a fire by simply removing one of the elements. Remember, if you remove the fuel source, or the flammable gas or vapor, or the ignition source, there is no way that a fire can start. And if a fire has started, you can smother the fire with foam, water, carbon dioxide, or dry powder to remove the oxygen and thus kill the fire. Let's try an exercise to test your understanding of the fire triangle. Three elements are required for a fire to start. Which of the following elements is required to complete the fire triangle? Drag and drop the correct element onto the fire triangle. When you're happy with your answer, press the Submit button. We have all seen fires such as wood burning for domestic heating, burning of rubbish and garden waste, and accidental burning of waste paper and so on. Consider a wood or coal fire. As a fire burns, there is the evolution of heat and the formation of gases, but neither is liberated rapidly enough to cause an explosion. The speed of the reaction is what distinguishes the explosive reaction from an ordinary combustion reaction. Unless the reaction occurs rapidly, the thermally expanded gases will be dissipated and there will be no explosion. In our industry, we contain hydrocarbons in pipework and vessels, and the content is usually under pressure. Therefore, in most cases, a gas release finding an ignition source will happen rapidly, and an explosion is far more likely to occur. Explosions happen due to the rapidly burning fuel gases expanding and creating a shock wave. This shock wave will cause overpressure, and even at low overpressures of 1 to 2 bar can damage any parts of the plant and equipment in the vicinity of the explosion. The shock wave and subsequent overpressure can also lead to further loss of hydrocarbons and may lead to additional fires and explosions. Where explosions take place in a confined space, such as a storage tank or pressure vessel, the overpressure can have deadly consequences for personnel working within the confined space. If the human body is exposed to overpressure caused by a shock wave, it can cause severe damage, sometimes fatal damage, to internal organs. So we know that if hydrocarbons are released and all elements of the fire triangle are present, a fire will occur. But what type of fire? In our industry there are two main types of fire: pool fires and jet fires. It is important to understand the difference between the two because the type of fire determines how it is fought. Select each link on screen to learn more. You must view each link before you can continue. Pool fires usually take place when hydrocarbon liquids are released under low pressure. The fuel will pool, continue to feed the fire, and keeps it burning. Therefore, the best method to extinguish this type of fire is to apply a foam blanket and smother it. Remember, this will remove the oxygen and break the fire triangle. Pool fires can be very dangerous, especially if they are situated underneath a storage vessel, as they can boil the hydrocarbons in the vessel to the point where there is a massive release of energy and a subsequent explosion. These types of fire are known as a BLEVE. BLEVE stands for Boiling Liquid Expanding Vapor Explosion. The release of energy from BLEVs is so great that extensive damage occurs in a large area surrounding the blast. Jet fires normally occur on high-pressure systems, and the escape point of the hydrocarbon is usually relatively small. Hydrocarbon fuel, either liquid or gas, is ejected through the hole, and if it finds an ignition source, forms a jet fire, with the flammable point being some distance from the release point. These types of fire can impinge on structural supports and can cut through steel very quickly, causing vessels and equipment to lose their integrity, fail, and often add further fuel to the fire.